Hello everyone, my name is Yanting, and my student ID number is 2021858502. My programming code is EE950, and my main supervisor is Professor Madaya Mohammed Murtaja bin Osman, and my co-supervisor is Professor Dr. Ismail. My pitch title is Multi-Objective Optimal Operation of AC-DC Hybrid Microgrid. There are three objectives. The first one is to implement the PSO and the simplex solution for a multi-time scale stochastic energy management strategy based on multi-scenario analysis for the grid-connected microgrid. And the second one is to utilize the GA solution as a multi-objective operation optimization method for microgrids with battery-driven isolated microgrid. And the third one is to propose the target cascade solution as an interactive optimization operation mode between the multi-microgrid and the active distribution network. Here we can see the research technical roadmap, and we can divide it into three steps. The first one is the theoretical basis. We can see we will do the microgrid overview, include research background and significance, research status at home and abroad, the development and evolution of microgrid. Also, we can get the research content innovation. The second, the modeling analysis involve the microgrid system analysis and the micro power mathematical mode. It's all the basic and the important. And the last one is the solve verification. We can see the three objectives. First one, the objective one, optimal operation of microgrid system in grid-connected operation mode. Also involve the two-stage stochastic optimization scheduling and the intraday rolling optimization scheduling. We can use the PSO and the simplex to salute. Objective 2, optimal operation of microgrid system in island operation mode. First, power difference control strategy considering practical constraints, and linear weighting method for multi-objective optimization modes, and we can use the genetic algorithm to salute. Objective 3, optimal operation between multi-microgrids and active distribution grids. Also involves high-level optimization mode of active distribution network and the lower layer optimization mode of multi-microgrids. We can also use the target cascade solution. And the first objective, grid-connected microgrid energy management strategy. Now we can see the step 1 and step 2. Step 1, day ahead. It's very important. Day ahead wind and solar AC and DC forecasting. Day ahead deterministic scheduling and multi-scenario analysis. Typical scenario of wind and solar AC and DC load. Intraday controllable unit power adjustment. So the two-stage integrated optimal day ahead scheduling planning, and we can see here day ahead two-stage dynamic optimization scheduling, that is, and then intraday rolling optimization scheduling. That is multi-time scale optimal dispatch framework of grid connected microgrid. And the second objective, overall dispatching framework of island microgrid energy management strategy. first and also the basic work. Renewable energy output forecast value, load forecast value, battery stage of charge, calculate net load at the current dispatching time. And then the battery adopts the power difference control strategy, so we can get the P battery. Also, it is the battery when it charges and when it discharges. And how? This one we can get the P battery. And then multi-objective optimal scheduling of controllable micro power output using improved GA, and we can get the PFC, PD, and PMT. We can get a whole result output. And the third objective is optimal algorithm for multi-microgrids and the active distribution network interaction. Also, the first step to establish a two-layer optimization mode of active distribution network with multi-MDs. The second step, to use the objective cascade method to solve. Also, the research feasibility in 2022, I have built a lab called the Microgrid System Lab. The smart microgrid system adopts a double busbar structure, integrating energy storage system, battery management system, distribution generation system, AC and DC load, energy management system, and monitoring system. Like the picture we can see, it's the lab microgrid system lab, and also the whole structure picture. And also the experimental feasibility. I have participated in the smart microgrid demonstration project of CRC Zhuzhou Institute. Relevant parameters are available, and on the basis of the above simulation software platform, the optimal operation of the smart microgrid system can be completed. And the physics results achieved so far. First, the microgrid system analysis, the structure and the composition. We can see a typical microgrid mainly includes DGs, electrical loads, energy storage device, and the control system. DGs exist in various forms of energy, including microturbine (MT), fuel cells, FC, photovoltaic (PV), and wind power generation (WT). The microgrid control system can manage all distributed power sources and loads within the microgrid in a unified manner. And also, when the PCC, this one point, is closed, the microgrid is in the grid-connected operation stage. At this time, the optimal operation of the microgrid needs to consider the output characteristic of the distributed power source, the control strategy of microgrid operation, and the power market, so as to maximize the operating benefits to the microgrid. And when the PCC point is disconnected, the microgrid, we can see it operates as an island. And the modeling analysis, we can divide it in DG. Also, the DG can divide into two parts: the clean energy, such as WT and PV, and the controllable DG unit, like FC, MT and DE. It all has the modeling and modeling. Also, the energy storage unit is different. It's different with the DGs. The energy storage system mainly plays its power tracking and peak shaving and value filling function. Control objectives charging during low load period, discharging during peak load. Control strategy fixed fifty and dynamic strategy. Like the isolated microgrid use the fixed 50 and the grid connected microgrid use the dynamic 50. Also this one, the first layer we use the power different control strategy. A power difference control strategy considering practical constraints is adopted to determine the operation mode of the battery. We can get the P battery, and on the basis, the output of each controllable DG is multi-objective optimal scheduling by using the improved GA, and then we can get the PFC, PDE, and PMT. So after 2 steps, we can get the total result output. And the power different control strategy considering practical constraints like this. We can divide it into the 3 steps, and after the 3 steps, we can get the result. And the isolated microgrid optimal operation mode objective function, we also use the two different functions, like the fuel cost and the environmental cost. It's different. And the constraints, we can consider the power balance constraints, active power output constraints, controllable unit climbing constraints. And the example analysis, this is the system structure, and we can get the basic date. This is the relevant parameter of controllable micro power supply, and this is the daily output power of renewable energy, demands of load and the payload. So we can get the part of the results, comparative analysis of storage battery and the 2 controllable strategies, and the single objective optimization results. This is the minimal running cost. This is the minimal environmental cost, and the multi-objective optimal results. We can get the lambda. Different lambda have the different results. So this is my Gantt chart. And now we are in the new year 2023, and this year my main project is the journal writing, and then do some work of the thesis writing. Now the list of publication. I have completed the first draft. The title is Optimal Operation of Isolated Microgrid System, including battery storage. And the status of thesis writing. Now the thesis can be divided into 6 charts. The first one is the introduction, and the second is literature review, and the second is optimal operation of grid connected microgrid, and the fourth is optimal operation of isolated microgrid, and the fifth is an injective optimal operation mode between the multi microgrid and the active distribution network. And the third one, the sixth one is the conclusion and field work. Okay, that's all. Thank you.